Greetings and welcome to, yes, another Big Ideas lesson, this time from the 8th grade Blue Book, lesson 5.1, and we've been talking about these and dealing with these for quite a while in our warm-ups, so these should be, the first two lessons should be fairly straightforward for you, but now we're going to get the true lesson on the video, and so we are going to deal with systems of linear equations, and we are going to talk about solving that system by graphing. And of course, we've been graphing for a long time, so if you're good at graphing, this is going to be straightforward. How can you solve a system of linear equations? Well, I'm kind of hoping that you can answer that essential question right now, since we've practiced quite a few of these in many of our warm-ups. Let's just get right to it. You were to take a couple set of notes from the top of the page 204 from the Big Ideas book that 8th grade Big Ideas book that I showed you how to access on our website. Takes you right to it. So you know that a system of linear equations is a set of two or more linear equations in the same variable. Okay? An example of that, they gave it right to you in the book, and that is y equals x plus 1, y equals 2x minus 7. I have a different example right here because it's the same thing. And then, of course, a solution to the system of linear equations in two variables is the ordered pair. It's the ordered pair that is the solution to each equation. All right? And if you're graphing it, it's the point of intersection. So let's get right down to the first thing that you're going to be asked to do in your assignment today and tonight and tomorrow, using the table to find the break-even point. So here we have two equations where it says C. C is going to represent the cost. That the cost is 25x plus 80. You could write that as y equals 25x plus 80. It's the same thing. They're using the letter C to represent cost, meaning that is the dependent variable. And then, of course, we have R, which they're going to use for revenue. So I'll just put it right here. C is cost. R is revenue. So cost is how much it costs you to produce something. And your revenue, that's how you're going to make from selling it. So they're saying the revenue is 45 times x. So what we need to do is put in x from this table. 1, 2, 3, 4, 5, 6, 7, and 8. So we're saying cost is equal to 25. Well, let me rewrite that again. I don't like it that way. We're going to say cost is equal to 25 times 1 plus 80. And when we do that, we get 105. Okay? And then we're going to keep going on. We're going to put in a 2. And we're going to do that, and you're going to get 130. And you're just going to keep going. You get 155. You get 180 when you put in 4. You get 205 when you put in 5. You get 230 when you put in 6. And so on, and so on, and so on, until you're done here. And what we're looking for is we're looking for a number in the revenue column that is either equal to or greater than the cost column, because that will tell us when we start actually making money, when we've covered our expenses. So obviously 45 times 1 is 45, and times 2 is 90, and times 3 is 135, and then we get 180. We see right there, that's the break-even point. So the cost to produce 4 items is $180, and when I sell those 4 items, I will make $180. Now I've broken even, and then after that, that's 225, and then 270, and so on. We don't need to go. But now you can see the difference. After our 5th item, we've actually made, well, 225 minus 205. We now have $20 that's actually extra profit. We've already paid for everything that it costs to produce it. Okay? This 25x could be the cost to pay your employees, the electric bill, all that stuff. All right? Then we just go on from there. Let's do another one. Cost is equal to 8x plus 24. Revenue is 12x. So when we do the cost, 8 times 1 plus 24 is 32. 8 times 2 plus 24 is 40. 8 times 3 plus 24 is 48, and so on, 56, and then you get 64, 72, 80, 88, 96. So 9 times 8 plus 24 is 96. And then, of course, if you know your 12s, 12, 24, 36, 48, 60, 72, 84, 96, 108. And you can see right here, this time it's 6. The cost of 6 items. This is using a table. Using a table means you're just taking this formula here, goes in for C, you do it, and you get the numbers, and voila. Pretty straightforward. Let's get down to the nitty-gritty. Solving a system of linear equations by graphing. You know how to graph. All right, so I'm going to use 2 colors here. I'm going to use blue and I'm going to use red. The first one I'm going to use is going to be blue. Y equals negative x minus 5. My slope for that is negative 1. My intercept for that is negative 5. So I come down here to negative 5, and I put my first point. Then I go down 1 over 1, down 1 over 1. And if I want to, I could go up 1, back 1, up 1, back 1. But if you have your straight edge and you can draw a really nice straight line, you won't need that many. You only need 3 points. Okay? And then I'm going to take red for my second. It's always nice to use different colors. And I'm going to come down here. My slope is negative 2. My intercept is negative 6. So when I put my point at negative 6, I can't go down 2 and over 1. So I'm stuck with going up 2, back 1, up 2, back 1. I have my 3 points. Well, and Viola, I also have my point of intersection right here, which is my ordered pair. X is negative 1, y is negative 4. And I can double check that. I can put a negative 1 in here, and I can say y equals a negative 1 minus 5. I had better get out negative 4, or I didn't get the right answer. So a negative 1, that's a positive 1, minus 5 is negative 4. And for the second one, y equals a negative 2 times negative 1 minus 5. Minus 6. And then, of course, negative 2 times a negative 1 is positive 2 minus 6 does give me a negative 4. So voila, it works. Let's continue to move forward using my blue. Y equals x plus 4. I'm starting here at 4. My slope is 1. Okay? My intercept is 4. You should write that down every time. So I'm going to go up 1 over 1, up 1 over 1. I have 3 points. And, of course, if I use my straight edge and I have precise and precision drawing, I will have no problem finding the answer. Obviously, I can't put a straight edge on this board. Y equals negative x. My slope is negative 1. My intercept is 0. So starting here at 0, down 1 over 1, down 1 over 1. I can now draw it up through here. And voila, I found my point of intersection right here. And that is negative 2 and positive 2. So there's my solution. We could verify it. We're going to move forward. Okay? My next set of equations, y plus 7 is equal to x. Well, I don't like that. I'm going to put it into slope-intercept form so I can graph, meaning I got to move the 7 to the other side. So that ends up with y equals x minus 7 when I subtract 7 from both sides. My slope, again, is 1. My intercept this time is negative 7. I'm coming down here at negative 7. I draw my 3 points, and with my precision tool, I can draw a straight line. And then I go to red for my next one. Again, I have to put that in slope-intercept form. This time I got to move the 4x. So y equals a negative 4x plus 3. And I come up here and say my slope is negative 4. My intercept is 3. So starting at 3, down 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And Viola, we got it right here. And that ordered pair is 2, negative 5. So 2, negative 5, is my solution. Straightforward, ladies and gentlemen. All we're doing is graphing. We're finding the point of intersection. We've done this. That's why I'm not spending a whole lot of time on it. We just know that every once in a while you got to put equations in slope-intercept form. So here we would have y equals a negative x minus 1. That's what you would get when you put that one in slope-intercept form. My slope being negative 1, my intercept being negative 1. Oops, I about to put a negative in it. So at negative 1, I'm going to go down 1 over 1, down 1 over 1. And, of course, I'm going to draw my line with precision. And I've said that a bunch of times, so hopefully I'm drilling it into your head. Already in slope-intercept form, so my slope is negative 2, and my intercept is negative 6. So again, I go down here to negative 6. I cannot go down 2 and over 1. So I'm going to go backwards. I'm going to go up 2, back 1, up 1, 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 2, back 1. I kept going until I found my point. I just wanted to do that. Do I have to? No, I could have done it with 3 points. If I drew a straight line, it would have done it for me. And so right here, my ordered pair solution, negative 5, positive 4. Negative 5, positive 4. And if I go in here and I put a negative 5 minus 4 equals 1. Well, a negative 5 is a positive 5. Minus 4 does equal 1. We can verify it all day long. Wyola. Ladies and gentlemen, let's go to our first quick write. I gave you a graph to take home and glue into your notes. So here you go. Y equals 2x minus 3. Y equals a negative 1/2 x plus 1. Graph that, and we will glue, well, we should have already glued it into our quick write place. And so, Viola. I don't know why I'm saying that word, but hey, when you're done, go take a quick break, talk to your mama, tell her how much you love her, do a chore for her or two, and then come back and finish up your notes. Bye.